What's the difference between carrier-based aircraft and land-based planes? It's not just about beefing up the landing gear. When we see land-based aircraft taking off or landing, the runway is usually pretty long. Even if they miss the runway, there's often grass or other space around. But on an aircraft carrier, space is limited. The planes on carriers are very different from land-based ones, and it's not just about strengthening the landing gear for catapult launches. Sure, the carrier deck might seem long, but a fixed-wing aircraft actually takes off from a point that's only about 100 meters from the start of the runway, not the full 300 meters you might expect at the back of the ship. When it comes to landing, the real action happens on the angled deck, and the available space is pretty tight. The differences between carrier-based aircraft and land-based planes are huge. For one, carrier aircraft are generally heavier, and there are a few reasons why they have to be designed that way. First up is the takeoff and landing requirements. These planes need larger wings and more control surfaces to handle rough sea conditions and turbulent winds on the carrier deck. The wing designs are more complex than land-based aircraft, as they have to maintain lift at low speeds and offer great low-speed handling. In simpler terms, the more movable wing surfaces, the more precise the control. Take the land-based version F-35A and the carrier version F-35C as an example. The F-35C has a larger wingspan and features separate flaps and ailerons. This allows it to carry more weight and maintain better control at lower speeds during landing. This lowers the chance of accidents due to mishandling. On the other hand, land-based planes typically use a combined flap and aileron system, which is lighter and simpler. The goal is to reduce weight and complexity. Of course, there are exceptions like the French Rafale. Next up, the structural strength of carrier aircraft needs to be higher to handle the rigors of sea operations, like corrosion from salt water. Because carrier-based aircraft take off and land in short distances, they need to have stronger landing gear. This isn't just about adding extra strength. The landing gear also has to withstand the vertical G-forces when the plane hits the deck after a high-speed approach. But the strengthening doesn't stop there. Whether it's a catapult launch or a ski jump takeoff, all carrier aircraft need to be designed for tailhook to grab the arresting gear when they land. This is one of the key differences between carriers and amphibious assault ships, which also have flight decks but aren't equipped with arresting gear. These arrestor systems allow the plane to come to a complete stop on a short deck. To handle this, carrier aircraft are fitted with tailhook, and the entire airframe needs to be built to withstand the forces generated when the hook engages. And let's not forget the special corrosion-resistant design for Navy aircraft. We often see ships coming back with rust after being at sea for a while, and that's not because of poor maintenance. It's the harsh marine environment. Salt water, sea spray, and high humidity can cause serious corrosion. To deal with that, the materials used for carrier-based aircraft are different from those used in land-based planes. For example, alloys like magnesium and beryllium are used instead of the typical anti-corrosion materials found in land planes. Plus, land-based aircraft often use honeycomb structures for strength and lightness, but those are prone to moisture absorption, which isn't ideal for the salty, damp conditions on a carrier. Carrier-based planes are packed with electronics, and salt water or rust can seriously mess with their systems. The corrosion not only weakens the structure, but can also compromise the plane's integrity. So, anti-corrosion design is a must. These planes need to be sealed up to keep out moisture and mold, and the structure needs to be designed so they can float if they have to ditch in the ocean. Unlike land-based aircraft, they need to sink more slowly, giving pilots more time to escape. Carrier-based aircraft must also have folding wings, wider landing gear, and tie-down devices. These planes need to make use of the limited space on the aircraft carrier, which is often subject to the ship's movement caused by rough seas and strong winds. To accommodate space constraints, nearly all carrier aircraft are designed with folding wings. The flaps and ailerons are typically divided along this fold. So modern carrier planes are mostly equipped with wing folding mechanisms to reduce their space usage. This allows for more planes to be stored in the hangar or on the flight deck, effectively increasing the number of aircraft that can be carried. Of course, there are some carrier aircraft that don't require wing folding designs, such as the F-14. Its variable sweep wing design allows the wings to fold back to 75 degrees, reducing the wingspan to just 10.15 meters. This configuration, combined with the way the aircraft is positioned, makes it highly space-efficient. In addition to the folding wings, carrier-based aircraft also tend to have a lower center of gravity and a wider landing gear stance. This increases their resistance to tipping over during the ship's movement, much like how a car's wheelbase contributes to stability. This design is crucial for carrier aircraft, but land-based planes generally don't need to consider this factor. Moreover, these aircraft have additional tie-down devices compared to land-based planes. This is mainly to prevent the aircraft from sliding or tipping over while stationary on the flight deck, which can be affected by the ship swaying. A stable tie-down device helps secure the aircraft, especially during rough seas. Before takeoff, you might notice the aircraft on a carrier doing a little wing workout. This is actually a pre-flight check on the movable wing surfaces. These complex control surfaces are a critical part of the plane's safety, and ensuring they're functioning properly before takeoff is essential for a smooth flight. When carrier-based aircraft are parked, their wings are often folded up. Even though they're designed to fold neatly, sometimes when they unfold, the movable control surfaces may not work as they should. Therefore, checking them before takeoff is a necessary step to prevent mechanical issues during flight, reducing the risk of accidents caused by malfunctioning parts. Finally, the weight of carrier aircraft and their lower sortie efficiency. All these added structural designs and reinforcements contribute to the fact that carrier-based aircraft typically weigh about 1 ton more than their land-based counterparts. For instance, the empty weight of the F-35A is 29,300 pounds, while the F-35C weighs 34,800 pounds. This weight difference also affects certain performance metrics, with carrier-based aircraft generally having slightly weaker performance compared to their land-based versions. Even though carriers are equipped with fairly advanced aircraft maintenance systems, they're still a simplified version compared to land-based airfields. As a result, the sortie rate of carrier-based aircraft tends to be lower than that of land-based planes, meaning they take longer to get ready for another mission. In conclusion, while both carrier-based and land-based aircraft are designed for specific operational needs, the differences between them go far beyond just beefing up the landing gear.